When I was a kid, I always had my eyes out for a cork and a matching bottle. That sounds kind of strange. Why did I love this combination? Well, I like to take baking soda and I like to combine it with vinegar and put it in the bottle and quickly cork it. And then that cork would go flying. Definitely don't try that at home. It doesn't sound safe. Here's the thing though, sometimes I would run out of baking soda. And this was quite an emergency, as you could imagine. But luckily, I found out that baking powder does pretty much the same thing. Here's an interesting thing I noticed though, baking powder didn't require vinegar. I could just put baking powder into water and it would make bubbles all by itself. I was puzzled by this strange difference. Well, if you're puzzled by this strange difference, you might be a future chemistry teacher. In any case, we're going to take a close look at the difference between our baking soda and our baking powder. And by the end of this lab, you'll understand just why baking soda requires vinegar, which is an acid, while baking powder does the job all on its own. Let's take a look. Let's begin by reviewing our lesson objectives. First, we'll introduce the required materials. Then we'll review the lab procedure. And lastly, we'll introduce baking soda and baking powder. Well, let's start with the required materials. You'll need baking soda, not shockingly, and you'll need baking powder. Then you'll need 2 to 10 cups. Why the range? Well, you can get by with 2 cups, but you'll have to wash the cups a lot after each step. So it's best if you have 10 cups. And into 2 cups, you would pour orange juice. Then in another set of 2 cups, you would pour milk. Another set of 2 cups, vinegar. Another set of 2 cups, lemon juice. You can see why here it's better to have 10 cups than to have to wash your cups over and over again. And the last 2 cups would get water in them. So here are your materials to gather. You can pause the video and gather these now, and then come back and finish the rest of the lesson. All right, well now let's review the lab procedure. What will we be doing? Basically, we'll be taking baking powder and baking soda and adding them to water. Now, just a clarification here, this looks like they're going in the same cup, but we're going to add a scoop of baking powder to one of the cups of water and a scoop of baking soda to another cup of the water to compare them. We're going to carefully record observations. Specifically, look for gas formation that you'll see as bubbles and note how much gas is produced. Once you're done with the water, you'll add 1 scoop to a cup of milk of baking powder and 1 scoop to a cup of milk from baking soda. Then you'll do the same and carefully record observations. I bet you can guess what's going to happen next. We'll add it to vinegar, and then lemon juice, and then orange juice. So why are we choosing all of these different solutions? What's the difference? The main difference is that each solution has a different pH. Here are the pHs of all the solutions. Water has a pH of just 7, milk 6.6, vinegar 2.5, lemon juice 2.5, and orange juice 3.8. So it's the pH that we're varying in each of these solutions. We're going to be comparing baking soda versus baking powder. Let's take a look at those chemical reactions so we can understand that well. Here is the reaction between baking soda and acids. So HNaCO3, or sodium carbonate, is our baking soda, and we're reacting it with an acid. As you saw, we used different acids in this experiment, so we're just going to represent an acid with a little H plus there. And what happens is, in all cases, when we react it with an acid, we get carbon dioxide, we also get water, and we're left behind with a sodium ion. Okay, let's think about the process of baking bread and how this relates to our baking soda. Let's say we have banana bread. Here's the trick. Here are all my ingredients for banana bread, and right down there in the bottom, we got baking soda. We also add mashed up bananas, as you well know. Those are acidic. They have a pH of 5. That's the key. In banana bread, it's actually your bananas which act as an acid to react with your baking soda. And that's why we get the fluffy, light nature. These holes that you see in our banana bread come from the carbon dioxide gas that's being released. The trick with baking powder, though, is that we actually don't need an acid. So let's say you're making sandwich bread. Here are all the ingredients for sandwich bread. And on the right-hand side, we have baking powder. But guess what? None of these ingredients are acidic. And so if there's no acid in the recipe, use baking powder. Why? Baking powder comes with its own acid. So baking powder comes built in with both of these things that are both from baking powder. So this is really a mixture of two things, an acid and baking soda. And when I take that and put it in water, it starts a reaction. So dissolving baking powder in water starts a reaction, just like we discussed in our introduction. Let's review what we've learned. First, we introduced the required materials. We saw that we'll need baking powder, baking soda, and a bunch of different solutions. Then we reviewed the lab procedure, where we saw that we will slowly add baking soda or baking powder to each of these different solutions. Lastly, we introduced baking soda and baking powder. We saw that baking soda reacts with acids to release carbon dioxide, which leavens bread. We saw that baking powder is basically baking soda with its own acid, so that you don't need an acid you add in your recipe. Hey!